everybody, and welcome to our lesson on scatter plots and predictions. Scatter plots are graphs of points that relate two variables to each other. Sometimes as one variable increases, the other also increases, and that creates a positive relationship, positive association. And sometimes as one thing increases, the other decreases, and that creates a negative relationship. Once we've graphed our data for our two variables, we can see which type of relationship we have, if any. Here's an example of a scatter plot and what it looks like. Someone who has charted the average daily temperatures at a beach and has also charted the amount of visitors at that same beach is indicating that as the temperatures are rising, the amount of visitors are rising. So there's a relationship there. We can see that visually from the data points. And the reason why these are useful is because they can help us make predictions about the future and further numbers that we haven't charted yet. So to graph one of these, we have to decide what is going to be our best scale for our x and our y axis after we've taken our measurements, and then we need to plot our points. So we're going to do that now. We have a table of measurements that we have recorded for populations of a town and then the number of restaurants in that town. So here is our x values here, so we're going to put those on the bottom, and we need to decide a good amount of increments for those. So we can see that the lowest one's 2, biggest one's 6, so we should probably just go up by 1 each time here. So let's make that label on the bottom, 1 through 6 for our x-axis. And then for our y's, change colors here, we have the lowest one is 25 and the highest one's 50. We could either do amounts of 5 here or 10. Let's just go with 5. So we'll start counting up by 5s until we've reached at least up into our highest number and maybe a little bit above. 35, 40, almost there. We'll go one more. Okay, and then we just have to simply plot our coordinates. So first one is 2 and 25. So let's find a color for our graph. Let's do this. Okay, so 225 would be here. And then we've got 335. Plot that one. 440. 539. Lower than that one, and then 6 all the way up to 50. Alright, so we can see there is a positive relationship of our data here. As the population is increasing, so are the amount of restaurants. So we can see that it's trending in that direction. So if we needed to make a prediction about further amounts of populations or lesser amounts of populations, we could do that. We could say generally there's going to be more for a bigger population. Alright, to make the best prediction possible, we need to create what's called a line of best fit, and that is just what it sounds like. We're going to draw a line through our data points and try to fit to the most points that we see. We're going to try to make it go through as many points as we can, and then we're going to come up with an equation for that line so that we can use that for any future value we'd like to see what's going to happen for, to make predictions about the future. So let's go back to our graph and let's create a line of best fit here. We're going to go through as many as we can. We want to go through them, or we want them to be as close to the line as possible. And then from that, we are going to pick out 2 points that are the closest, or closer than other points, to form our equation of our line of that best fit. So I see a couple of options here, but let's try our 335 point here. You can see that one. And our last one here, 6 and 50. Let's take those two and form the equation of this line. Alright, to do that, we're going to need 2 things. We're going to need a slope and an intercept, the m and the b in the y equals mx plus b form. So we've chosen our points, so we're going to write those down. So we chose 335 and 6. Okay, so to find slope, we're going to use the slope formula, which is the difference in the y's over the difference in the x's, rise over run. y2 minus y1 over x2 minus x1. So let's do that here. So we've got 50 minus 35 over 6 minus 3. And this is going to give me a slope of 5. Now I need one more thing. I need a y-intercept. So to find that, I'm going to choose one of the points that I've already pulled. Let's just choose this first one. And I'm going to fill in that plus my slope to the y equals mx plus b, and b will be the only thing missing, so I'm going to solve for b. So let's do that up in this space here. So y equals mx plus b, so I'm going to put in my y value of the point I've chosen, equals, I'm going to put in my m value, m x plus b. Easy as that. So 35 equals 15 plus b. I'm just solving. I'm trying to get b alone now, trying to solve for that variable. So I'm moving everything away from that variable using solving steps. So now we can see that we have our y-intercept. So once you have those two things, you can form your equation of your line of best fit. So we have y equals 5 was our slope, x plus 20. Now this is useful because I can throw in any x value and find the matching y. For instance, ours was relating the population in the town to the restaurants. So if I wanted to go really big and I knew I was visiting a town that had maybe 10,000 instead of ours, which just went up to 6 in our chart, I would put 10 in for x, I would multiply by 5 and add 20, and then I could come up with the amount of restaurants that would probably be there according to our data if it followed the same pattern. So that's why these are really neat. All right, so let's do that. Let's test the town of 10,000. So we said it was 5x plus 20 was our equation. So let's see how many restaurants we might have to choose from if we visited that town. So 5 times 10 is 50, add our 20, and that one's higher than anything else we saw on our table, is 70 restaurants. All right, the more close that your lines are together on your scatter plot, the stronger the association is, and the more reliable that association is to make predictions off of. So if you see a scatter plot that has values that are very close together, it's going to make a very reliable equation for you to make predictions from. But if you see one that has the points sort of scattered all over the place, even though it may be forming a general positive trend or negative trend, if they're more scattered, it's going to be harder to make predictions from that, but you can still do it using our method of line of best fit. So this concludes our lesson on scatter plots and making predictions.